right, 4.1, we're going to be graphing polynomials. So polynomial functions, it says recall that a monomial is a number which is a variable or the product of a number and one or more variables with whole number exponents. So a monomial just means one term. A polynomial is a monomial or the sum of monomials. So a polynomial, poly, means many. So that would just be many terms. So a polynomial is a function of this form. In standard form, we always start with the highest degree. So just like when we put our quadratics in standard form, we always started with the x squared, then the x, then the constant. Same thing with the monomials or polynomials, except here we're going to have higher than just x squared. So exponents are whole numbers, and the coefficients are real numbers. The number in front of the highest degree is the leading coefficient. And anything that doesn't have an x is a constant term. So this would just be like a number. So a number without an x. So a polynomial function is in standard form when its terms are written in descending order of the exponents from left to right. So highest to lowest exponents. So the exponents is what makes it in standard form. All right, so we can classify our polynomials. If it is just a number without an x, it would be a constant. If it has an x with no degree, the degree is technically 1. It would be like x to the first power. We call that linear. If our highest degree is x squared, then that would be quadratic. Quadratics is what we've been dealing with in chapter 3, where we graph parabolas, had to factor, stuff like that. So we've been dealing with x squareds, which are quadratics. If it's x to the third power or x cubed, that would be cubic. And then if it's x to the fourth power, we call that quartic. You could think about it as like 4 quarters. So these are just vocab words that we use to describe our polynomials. So this is how we describe them by the degree. So example 1, we're identifying polynomial functions. So it says decide whether each function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So in A, how would we describe this by the degree? What's our highest degree that we have? 3. The highest degree is 3. So what do we call something with the highest degree of 3? Cubic. Now, is this in standard form? Yeah. We start with the highest degree. Then we have our x and then constant. So yes, this is in standard form. And what's our leading coefficient here? So remember, leading coefficient is the coefficient, the number in front of the highest degree. Perfect. -2. -2 is our leading coefficient. Coefficient means the number in front of what gets multiplied to the x. The leading coefficient would be like the first one that's in standard form. Now, I also wanted to describe it by the type. It didn't mention this on the last slide, but to describe it by the type of polynomial, we have four different types. So if it just has one term, we would call that a monomial. If we have two terms, we call that a binomial. What do you think three terms would be called? Trinomial. And four terms or more, we just call it a polynomial of however many terms we have. So if there were four terms, we would say a polynomial of four terms. If there were five terms, we'd say a polynomial of five terms. So the only ones with special names are 1 through 3. So what type of polynomial do I have for A? A trinomial, because there's 1, 2, 3 terms. So this would be a trinomial. And terms are always separated by a plus sign. Plus or minus sign. All right, let's take a look at C. So right below A. Is this in standard form? No, because it doesn't go in descending order. Do you think this is a polynomial? No. Why not? Well, in order to be a polynomial, whether it's a monomial, binomial, any type of polynomial, it has to have positive exponents. Does C have all positive exponents? No. No, it has that -1, so this would be not a polynomial. Okay, let's look at B. For B, is this in standard form? How would we make it in standard form? Which one would have to come first? The square root 2x to the 4th power. What would come next? So minus 0.8x cubed and then minus 12. So this would be in standard form because we always start with the highest degree and then go down. Now, if I classify it by degree, I always look at the highest degree to classify it. What do we call something with a degree of 4? Quartic, awesome. We think of it like 4 quarters, so quartic. Now, the type of polynomial depends on how many terms we have. How many terms do I have here? 3. So what do I call something with 3 terms? Trinomial. Oh, and then the last type, the last is the leading coefficient. What is my leading coefficient here?
2.
Square root 2. So it's whatever's in front of the highest degree, the coefficient in front of the highest degree. So that would be square root 2. All right, and let's look at D. Do you think D is a polynomial? What's different about D?
Yes. For B, why did you put the trinomial and not the 4?
Trinomial, because there's 3 terms. We have 1, 2, 3 terms. The degree of 4 is quartic. So we classify it by the degree and the number of terms. So 2 different sets of vocabulary. What makes D different? There's an x as an exponent. A polynomial can't have x as an exponent, so this is not a polynomial. So we can't have negative numbers in the exponent as a polynomial, and we can't have x in the exponent. All right, so let's look at 1. Do you think this is a polynomial? Yes. Is it in standard form? No. How would I rewrite it in standard form? Just 1.6 x squared? Negative 1.6. That negative goes with the 1.6. So negative 1.6 x squared. What would come next? Minus 5x plus 7. Awesome. All right, so let's classify it by the degree. What is my highest degree? 2. So what do I call something with the highest degree of 2? Quadratic. How many terms do I have here? 3. So what do I call something with 3 terms? Trinomial. And what's my leading coefficient? Awesome, negative 1.6. All right, for 2, do we think this is a polynomial?
No.
What makes it not a polynomial? The negative exponent, so this is not a polynomial. And for 3, do you think this is a polynomial? Yes. Is it in standard form? No. How do I rewrite it in standard form? Perfect. Perfect. Awesome. So let's classify it by the degree. What's my highest degree? 4. How do I classify something of the degree 4? Quartic. How many terms do I have? 3 terms. How do I classify something with 3 terms? Trinomial. And then what is my leading coefficient? 3. Awesome. So example 2, we're evaluating the polynomial function. It'll give you a value for x. And all we have to do is plug it into all of the x's in our equation and solve using your order of operations. So I have f of 3 because it tells me x is equal to 3. And I plug that into all the x's. So 2 times 3 to the 4th power minus 8 times 2 squared. 8 times 3 squared, sorry, x is 3. Plus 5 times 3 minus 7. What do I have to do first? The parentheses, but I don't have any math going on in the parentheses, so what would I do next? The exponent. Got to do the exponents. So 3 to the 4th power is like saying 3 times 3 times 3 times 3. Awesome. 3 times 3 is 9. 3 times 3 is another 9. 9 times 9 is 81. Perfect. So 2 times 81 minus, what is 3 squared? 9. Yes. And then I have 5 times 3, which is 15, minus 7. I have some more multiplication going on in there. What is 2 times 81? 162. What is 8 times 9? 72 plus 15 minus 7. And then from here, we're just going to add them and subtract them together. So 162 minus 72 would be 90. 90 plus 15 is 105, and 105 minus 7 would be 98. Awesome. So you would write your answer like this. F of 3, because it started as f of x, but it told us x was 3, so f of 3 is equal to 98. So here it talks about the end behavior of polynomial functions. So again, there's no math going on here to determine the end behavior. It's kind of just memorization. So if our degree is odd, so let's say it was like an x to the 3rd power or x to the 5th power. If the degree is odd and the leading coefficient is positive, then our left arrow of the graph is going to go down and our right arrow goes up. So it uses this as notation, so like f of x goes to infinity as x goes to negative infinity. You could say that the left falls and right rises. So because the left arrow is going down, we just say that it falls. Right arrow goes up, so it rises. Or you could say falls left, rises right. Now if the degree is odd, but the leading coefficient's negative, then it flips. So it rises left, because our left arrow is now pointing up, and the right arrow points down, so it falls right. Yeah, so if this was like negative x cubed or negative x to the 5th power. So one way we can remember when it's odd, the arrows go in opposite directions. So when the degree is odd, the arrows go in opposite directions. Now, if our degree is even, the arrows are going to go in the same direction. So if the highest degree is even and the leading coefficient is positive, so if it was like an x squared graph or x to the 4th power graph, we rise left and right. So it goes, the arrows go up and up. And then the opposite happens if it is even and negative. So if it was like a negative x squared, our arrows go down and down, so we'd say falls left and right. So one other thing to help us remember, if the leading coefficient is positive, then the right arrow goes up. So notice how here in these two boxes, we had positive and positive. The right arrow is always pointing up. If it's negative, the right arrow goes down. So if you remember that odd is opposite, even is same, and if the leading coefficient is positive, the right arrow goes up, that's all you need to do. So I would say the first thing you want to write is the right arrow, if it's positive, and then figure out is it even or odd, and that'll tell you the left arrow. It's either going to go in the same direction or opposite directions. All right, so for example 3, we're going to describe the end behavior of the graph. So when we describe the end behavior, we only look at the highest degree. So which term here has the highest degree? The negative 0.5x to the 4th power, so this one. everything else does not matter. So we're only looking at this one to describe the end behavior. Is my leading coefficient positive or negative? Negative. So what does that tell me about the right arrow? It falls. So it goes down. So the right one falls. And then looking at the degree. Is my degree even or odd? Even. So does that tell me they go in the same direction or opposite? Same direction. So that means the left one also falls. So you could say falls left and right. Or falls left and falls right. I'm going to do number 6 first. We're going to describe the end behavior of the graph. So which term do I need to look at here? The first one, the one with the highest degree. The rest of it does not matter. Is my leading coefficient positive or negative? Positive. So what does that tell me about the right arrow? The right arrow goes up, so we could say rises right. So now our degree, is it positive? Is it even or odd? Odd. Does that mean the arrows go in the same direction or opposite directions? Opposite. So what's the left arrow going to do? Fall. So falls left. All right, let's do one more. We're going to do number 4. So 4 we just have to evaluate. And it says when x is equal to 4. So what do I need to do? Plug in 4 into all of the x's. So I have f of 4 is equal to negative 4 to the third power plus 3 times 4 squared plus 9. Now a super duper common mistake is that people, when they plug it in, they won't put it in parentheses. So they'll think the negative 4 is what gets the exponent. That negative is on the outside. So you cube the number first, do the exponent of the number first, and the negative just stays outside. What is 4 to the third power?
64.
Awesome. It's like saying 4 times 4 times 4. 4 times 4 would be 16, and then 16 times 4 would be 64. So, awesome. Negative 64, because that negative just stays at the outside. The next, I have 3 times 4 squared. What is 4 squared? Awesome. Good job, George. 48. 4 squared would be 16, and 3 times 16 is 48. And then plus 9. So now I have negative 64 plus 48.
Negative 16.
Awesome. Negative 16 plus 9 is what? Negative 7. So f of 4, when we plug in 4 into the x, we get negative 7.